So this is the test for identification of gases. So first we start with hydrogen gas. So first we see how hydrogen gas can be produced. When a dilute acid is added to an active metal like zinc, it can produce hydrogen gas. So in this example, I have taken zinc metal and dilute hydrochloric acid, which will produce hydrogen gas. And when hydrogen gas is produced, the observation will be brisk effervescence of a colorless gas. And this colorless gas is nothing but hydrogen, which burns with blue flame. Hydrogen gas burns with blue flame. So that is the confirmatory test for hydrogen gas. And the second one is water vapor or water. So in this, when you take copper sulfate crystals, like blue color copper sulfate crystals in a test tube, and when you heat it, it will produce anhydrous copper sulfate and the water will come out as water vapor. And when you send this water vapor through anhydrous copper sulfate again, so then that anhydrous copper sulfate again will turn back to blue color. That means when you add water to anhydrous white copper sulfate, that copper sulfate will gain its blue color. So that is the confirmatory test for water vapor or water. And the next one is oxygen gas. And oxygen gas can be produced by heating potassium chlorate. So potassium chlorate gives oxygen gas. And how do we test oxygen gas? One, it rekindles glowing splint and it turns alkaline pyrogalal to dark brown color. So these two are the tests for oxygen gas. And the next one is carbon dioxide gas. And when you add a dilute acid to any metal carbonate, it will produce carbon dioxide gas. And when carbon dioxide gas is produced, we see brisk effervescence as the observation. And this brisk effervescence is nothing but carbon dioxide, and this carbon dioxide turns lime water milky, but it has no effect on potassium permanganate and potassium dichromate. So carbon dioxide is very, very important for the examination point of view. So test for carbon dioxide. One, it turns lime water milky but has no effect on potassium permanganate nor on potassium dichromate. And the carbon dioxide gas is produced from the metal carbonates. So this is also very important. And the next one is sulfur dioxide gas. And this sulfur dioxide gas can be produced from sulfides by adding dilute acid to these metal sulfides. So when you add dilute HCl to sodium sulfide, it gives sulfur dioxide, which has suffocating odor, and it also turns lime water milky. So this is the common property shown by both carbon dioxide and sulfur dioxide. They both turn lime water milky. And this sulfur dioxide can decolorize potassium permanganate and it can turn potassium dichromate to clear green solution. Whereas in case of carbon dioxide turns lime water milky but has no effect on potassium permanganate and potassium dichromate. But in case of sulfur dioxide, it also turns lime water milky and it decolorizes potassium permanganate and it turns potassium dichromate to clear green solution. So the color changes are very important in this case. So there is a confirmatory test for sulfur dioxide. And then the sixth one is hydrogen sulfide gas. Hydrogen sulfide gas can be produced from a metal sulfide by adding a dilute acid. So here in this case, sulfuric acid, dilute sulfuric acid is added to ferrous sulfide, which is giving hydrogen sulfide gas. Now it is easy to identify hydrogen sulfide gas with its rotten egg smell. Hydrogen sulfide gas has rotten egg smell, and it also turns lead acetate paper to silvery black. So either with rotten egg smell we can identify H2S, or with the help of lead acetate also we can identify this hydrogen sulfide gas. And the next one is chlorine gas. And the chlorine gas is produced when concentrated HCl is heated with manganese dioxide. And you will see a greenish yellow gas, that is chlorine gas. It is also acidic in nature, so it turns moist blue litmus to red color, and then because of its bleaching effect, the red color of the litmus paper will disappear. And chemical test for chlorine gas, it turns starch iodide paper to blue black. Then the eighth gas is nitrogen dioxide. This nitrogen dioxide can be produced by heating any metal nitride except potassium and sodium. So in this case I have taken lead nitrate, which on heating gives reddish brown vapors of nitrogen dioxide. So nitrogen dioxide has reddish brown color, and it is also acidic in nature, so it turns blue litmus to red color. And it gives violet vapors with potassium iodide crystals. It gives violet vapors with potassium iodide crystals. So that is the confirmatory test for nitrogen dioxide. And then ninth one is hydrogen chloride gas. So hydrogen chloride gas, or HCl, can be prepared by heating sodium chloride and concentrated sulfuric acid together. So which gives a colorless gas with pungent odor. And this HCl gas turns moist blue litmus to red color. And the chemical test for HCl gas, when you take a glass rod dipped in ammonium hydroxide, and when it is brought near HCl, it gives dense white fumes, which is nothing but ammonium chloride vapors. And when HCl gas is passed into silver nitrate solution, it gives a white precipitate of AgCl, silver chloride, which is soluble in excess ammonium hydroxide. And ammonium chloride means the last gas is ammonia gas. So ammonia gas is prepared by heating ammonium salts like ammonium chloride with calcium hydroxide. So this gives ammonia gas, which also has a characteristic pungent odor, and ammonia is the basic gas, means which turns moist red litmus to blue color. And this will give you dense white fumes when it reacts with concentrated HCl. And when this ammonia gas is passed into copper sulfate solution, it gives, or it forms, pale blue precipitate. And when you pass excess ammonia gas, it will give you inky blue solution. So this is how we can identify ammonia gas. So these are the chemical tests and identification of gases.